Welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers. In this episode, we're going to explore a classic Hubble image. One of the Hubble images that first brought the attention of Hubble's amazing imagery to the public, and one that is still one of the favorites today. It is this image called the Pillars of Creation. And in it, you can see three dark gas pillars that are brightly highlighted by this yellow ionization front around those pillars. And inside those pillars, stars are forming. So that's why they're called the Pillars of Creation. Beautiful pillars, but they have star formation going on inside. And we have some new images of these that reveal details on both small and large scales. Let's start with the largest of scales. Let's show you where it is on the night sky. This is an image directed toward the constellation of Sagittarius. And although mythology may tell you that Sagittarius is the archer, if you know the star pattern, well, Sagittarius, it's a little teapot. It's short and it's stout. Here is its handle, and here is its spout. Now that spout points toward the center of our galaxy, which is located approximately here. So when we view the constellation of Sagittarius, we're looking toward the center of our galaxy, and we have a very rich field. There are a lot of star clusters and nebulae. The ones denoted here with these M numbers are Messier objects. These Messier objects are generally the star clusters and the nebulae, or sometimes they're both. The Eagle Nebula is also known as Messier 16, and it's located here, well to the left of the galactic center. If we zoom in on the Eagle Nebula, you can see the structure of it. Here, I suppose, is the head of the eagle, and here is its body with its wings extending out to either side. Now, I know you've got to sort of squint your eyes and use your imagination to see it, but this is actually better than most of them. Let's zoom in a little bit further, and you can see what's happening inside the nebula. There's this bright cluster of stars, and it is the energetic radiation and the stellar winds from these bright stars that have created a cavity in the gas cloud. If I overlay the Hubble image, you can see that the pillars are pointed directly toward that star cluster. Again, it is the energetic radiation streaming down that blows away all the low-density gas, leaving behind only the high-density gas of the pillars. So this Hubble image is from 20 years ago, and it was taken with an instrument called the Wide Field Planetary Camera 2. You can tell because it has this characteristic stair-step shape. In Wide Field Planetary Camera 2, there are three wide field chips, the upper left, the lower left, and the lower right, and one chip that's called the planetary camera in the upper right. Now the planetary camera chip has twice the resolution on the sky as the other chips, and therefore it only covers 1/4 of the area on the sky. Since then, we have replaced the Wide Field Planetary Camera 2. In 2009, we installed the Wide Field Camera 3, or I will sometimes call that WFC3, and the other one WFPIC 2. WFC3 took advantage of a decade and a half of improvements and has higher resolution, a larger field of view, and better technology in its optics. With WFC3, we're able to revisit the pillars in Eagle Nebula, and we got that image. Now, the original was stunning when it came out, but I think this is even more dramatic. And if I overlay the original image, you can see that it covers a much larger region on the sky, about 6 times the area on the sky is covered in the new image. And because of the higher resolution of the detectors, it has about 20 times more pixels. So let's take a look at the comparison between the old and the new. We're going to start with the top of the middle pillar. This, in the old image, is the planetary camera chip. So this has the higher resolution in WFPIC 2, and that resolution is roughly similar to the resolution of WFC3. So the difference between these two images really shows the difference in the detection technology. And you can see that there are similar features in the old image as in the new image, but they're just a little bit clearer, a little bit finer in the new image. The other thing you notice is that around the tops of the pillar, you can see sort of a speckling, we call this noise. This is the low-level brightness of an image, and we can see noise in it. There is noise in the WIFC-3 image, but it's at much lower level. It looks a lot smoother. This region is in the middle of the tall pillar on the left, and here the resolutions of the detectors are different. So you can see a fuzziness in the old image and a clearer view in the new image. One particularly interesting feature is that these ionization fronts, that yellow region along the edge of the dark gas, that was unresolved in the original image. It is also unresolved in the new image, which means this is a very thin layer on the edge of the dark nebula where the ionization is happening. The other thing you notice is these region here where there are two stars forming. One of them is sort of in a cavity inside the nebula, and the other one's sort of at the top of what a small pillar that sort of resembles a smokestack to me. You may also notice these artifacts up here. They're kind of streaks. Well, what they are actually just the diffraction spikes of a bright star that's located off this region of the image. If we move to the top of the tall pillar, we can definitely see again the difference in the resolution. There's a fuzziness to this image that becomes much more clear in looking at the new image. And I love this region of the image because it's got all these small fingers of dark gas, and they're brightly silhouetted by the ionization fronts. And these fingers could have really dense gas inside them, and they could have stars forming inside them. We do see evidence of one star forming down here, because when stars form, they often give off these energetic jets of radiation, oppositely directed jets, and here you can see the jet coming from a newborn star right in there. And these jets are moving away from the star at about 500,000 miles an hour. And if we compare them carefully, we can actually see the motion of those jets. So here is the 1995 image and the 2014 image, and the arrows indicate the end of the jet between those two epochs. Over 19 years, that jet traveled 60 billion miles. Not much changes in a human lifetime in the universe, but here we can actually observe something changing on our timescales. Those are the direct comparisons of the old versus the new, but having a larger image provides us some other interesting details to look at. For example, let's just take a look at this middle pillar. You can see that the top of it is what we saw in the old image, but then we had a relatively cut-off view here. When we extend it, you can see the gas flowing off the end of it. This really drives home the point that it's the radiation and winds from those stars that are blowing back the gas and getting rid of the low-density gas. It also, according to a friend of mine, makes it the Dementor pillar, because it resembles the computer graphics effect used for the Dementors in the Harry Potter films. There's another cool region down here in the lower right of the image. If I blow that up to full screen, you can see that we've got some tiny little pillars. These are individual small pillars that are very much like those fingers that we saw at the top of the tall pillar. However, these are isolated, and I would guess that these would evaporate away relatively quickly sometime in the future. There are a lot more details. There's lots of cool stuff all throughout this image. And if you go to our website, you can download all 60 million pixels of it. You can go through it and explore it to your heart's content. Here, I'm going to go in a different direction, because WIFC-3 not only improved our ability to observe invisible light, it also improved our ability to observe infrared light. So using the infrared detectors on WIFC-3, we were able to get this image. Let me go back. Visible light, infrared light. Really cool how it looks so different in infrared light. The first thing you notice is that there's a tremendous number of stars in the image that you don't see in the visible light. Well, that's because infrared light has longer wavelengths. The longer wavelengths can penetrate through the gas and the dust better, allowing you to see the stars both inside the nebula and the innumerable stars that are behind the nebula. You also notice that there are the pillars, structures are here, but they look kind of ghostly. They aren't really that solid in infrared light as they are in visible light. Again, this is because the infrared light will penetrate through some of that gas and dust. Let's explore some of those comparisons, but this time doing visible light versus infrared light. We go back to the top of the middle pillar. And the first thing I notice about this is that how opaque the gas is in infrared light. This indicates it must be really dense gas in here. Also notice that there is star formation going on inside the pillar. Here in the visible light image, you see a little bit of red that indicates star formation. But in the infrared, you're looking through some of that gas into the cavity inside the pillar in which you can see stars that are forming. Now, I know it's not perfectly clear, but infrared has a lower resolution than visible light. That's again because of the wavelengths. The resolution of a telescope is proportional to the wavelength that you're observing. If you wanted to get this type of the visible light equivalent resolution in the infrared, you'd need a larger mirror to the telescope. That will come with the James Webb Space Telescope launching in 2018. Until that time, we're going to have to deal that our infrared images are a little bit lower resolution than our visible light images. If we move to this region, which is the one in the middle of the tall pillar on the left, we can see that again we have some dark, dense gas here, but in the lower left, you can actually see through the gas to see stars beyond the nebula. That indicates that it's lower density and it's somewhat transparent in infrared light. We can also see that that star at the top of what I call the smokestack is very bright in the infrared. At the top of the large pillar, we get to the region where we have those fingers. And here's where you can see the ghostliness of it, because the fingers are brightly silhouetted and, prominent in the visible light image, but they're very nebulous in the infrared image. That indicates that they aren't that high density. It doesn't look like we'll have stars forming in this finger up here, because otherwise there would be a dense knot of gas that would be opaque to infrared radiation. We can also see another region of star formation. There's only a hint of it in the visible light image with that tiny little bit of red, but here we can see the big white region that again stars in formation inside the pillar. If we pull back to take a look at the top half of the large pillar, we get to see just how ghostly it really is. In visible light, it looks like a relatively solid pillar. But in infrared light, you can see that the middle section is actually low-density gas. And this is a very important point about these pillars. What they are these dense regions up here that create the pillars by the shadow in visible light. Infrared light shows them to be relatively transparent. You can see a lot of, if you look at this image in detail, you can see a lot of these dense regions that don't have dense regions behind them, but in visible light they look as if they're dense because they are in shadow. There's one other cool region I want to talk about, and it's actually at the bottom of the smallest pillar. Now when I zoom that up to full screen, you might look at this and say, well, those aren't the same regions, but I assure you they are. See, you can see that those two stars there in the visible light image appear here in the infrared image. Almost all the other stars don't appear in the visible light image. And in particular, you've got these 4 really bright stars in the infrared that are hardly visible at all. Matter of fact, when I went very carefully through it, and those 2 very faint stars in the visible light image are the left 2 stars here in the infrared image. Whereas these ones, they don't appear at all in the visible light image. These must be very low mass stars, because while a star like the sun emits most of its light in visible light, the very smaller stars, the lower mass stars, emit most of their light in infrared radiation. So here we are looking at two very low mass stars, very bright, and it shows you just the difference you can get by using multi-wavelength astronomy. Here are that trio of images of Hubble's views of the pillars in the Eagle Nebula. the original 1995 image, the 2014 visible light, and the 2014 infrared. These images show off how Hubble has improved its detectors over the years, how we can get larger fields of view, how we can get higher resolution, and how we benefit from using multi-wavelength astronomy to explore the universe. Thanks for watching. I'm Dr. Frank Summers. Star clusters and nebulae. The ones denoted here with these M numbers are Messier objects. These Messier objects are generally the star clusters and the nebulae, or sometimes they're both. The Eagle Nebula is also known as Messier 16, and it's located here, well to the left of the galactic center. If we zoom in on the Eagle Nebula, you can see the structure of it. Here I suppose pattern. Well, Sagittarius, it's a little teapot. It's short and it's stout. Here is its handle, and here is its spout. Now that spout points toward the center of our galaxy, which is located approximately here. So when we view the constellation of Sagittarius, we're looking toward the center of our galaxy, and we have a very rich field. There are a lot of stars. Welcome to Hubble's Universe Unfiltered. I'm Dr. Frank Summers. In this episode, we're going to explore a classic Hubble image. One of the Hubble images that first brought the attention of creation. Beautiful pillars, but they have star formation going on inside. And we have some new images of these that reveal details on both small and large scales. Let's start with the largest of scales. Let's show you where it is on the night sky. This is an image directed toward the constellation of Sagittarius. And although mythology may tell you that Sagittarius is the archer, if you know the star path of Hubble's amazing imagery to the public, and one that is still one of the favorites today. It is this image called the Pillars of Creation. And in it, you can see three dark gas pillars that are brightly highlighted by this yellow ionization front around those pillars. And inside those pillars, stars are forming. So that's why they're called the Pillars